Hello and welcome. In this video, we are going to take a look at how to parse the Microsoft Windows version of the console ARP table using Matlab and regular expressions. Now, this video actually was prompted by a question from one of my students. I thought it would be kind of an interesting little challenge to play around with this one and also show everyone how you sort of evolve your regular expressions or the pattern that you're looking for to ultimately find the results that you want in a body of text. So this video assumes a couple of things. Number one, that you have some familiarity with the whole address resolution protocol or the ARP protocol. The idea is that it's fundamentally a way of resolving IP addresses and MAC addresses. That is, again, for the media access control layer in the OSI model. And the other thing that this video assumes is that you have used a little bit of regular expressions. I'm not going to go as in depth with the basics of regular expressions. Instead, I'm just going to focus on solving this problem. Now, I will tell you that we are going to be playing around with some regular expressions, and particularly, I am going to be playing around in this case with the single character meta character. In other words, I'm going to be looking for patterns involving such a wide assortment of values that I really can't explicitly match them. And so in this case, I'm going to be very heavy-handed, if you would, and I'm just going to be looking for any single character. The other trick that I'm going to employ in this one is going to be the new line character. And also I'm going to be relying pretty heavily on these quantifiers, particularly we're going to experiment a little bit with the star or 0 or more times consecutively, as well as 1 or more times consecutively. And then in addition to that, we're going to take this just a step farther, and I'm actually going to look at these quantifier modes, if you would, where you can control exactly how greedy a quantifier is. And specifically, I want you to take a quick look at this concept of a greedy expression and where it matches as many characters as possible, or this lazy expression where it matches as few characters as possible. And I'm going to attempt to the best of my ability to demonstrate as many of these possibilities as I can in this video without making too long. And what I'm also going to do is I'm going to post my bad or non-working regular expressions in the comments, because it's probably going to be advantageous for you to see how you can go wrong with this and sort of the evolution of the regular expressions. So let's go ahead and get started. We're going to go ahead and start by launching the ARP command from the console. Give me 1 second here. We're going to start off. I am putting myself in my software directory. It doesn't really matter which directory you are in for this. The ARP command will run from any location. And there's nothing really all that interesting about my ARP table. I have a couple of interfaces on here with a mix of static and dynamically assigned IP addresses. And again, there's nothing magic about this. Your ARP table will get updated as you ping devices and as you explore your network. But what we want to do is we want to take a look at the patterns, and you'll see here there's two things going on, is that the IP address, physical address, and type are grouped by the interface in which they communicate on or communicate with. And so we're going to be looking at two different patterns. And what we're going to do is we're going to start off first with one of the individual patterns. In other words, essentially what I want to do is I want to be able to capture the IP address, the physical address, and the type, so that we can ultimately build a table of our own inside of Matlab. We're going to just use a cell array for this particular example here. But ideally, what I'd like to do is I'd like to be able to provide the IP address as the interface, the destination interface, or rather the destination IP address, as well as the physical address for the destination address, and then the type of ARP assignment. So ultimately, we want to have a 4-column cell array that then maybe we can give to somebody else to look at for the purposes of a lab or something along those lines. So let's go ahead and get started. The first thing I'm going to do is I'm not going to run the command in MATLAB. I'm just going to try to pick apart one of the lines in my ARP table. And so let's go ahead and call this one sample. And We're going to just go ahead and paste this in here. Now, whether or not you captured the first spaces, it doesn't really matter. You'll actually see why, because we're more interested in the patterns and then the void or the spaces in between the patterns that we're wanting to capture because of the way regular expressions, because of the way they work. You don't necessarily have to worry about the things in front of and at the end of what you are trying to capture, usually, not always. And so we're going to go ahead and start off by saying results then is going to be equal to the reg xpi. We're going to pass through the sample. And I tell you what, let me keep consistent here. I'm going to use lowercase. And we're going to run through our sample here. And we're going to start off with a regular expression that we've actually used in a couple of other videos. And that is the one for the IP address, in which we are going to be looking at a /d plus pattern followed by a slash period. If you recall, I had to put the slash in front of the period technically to exclude or exempt the period, because otherwise that's essentially a wild card or a meta character that would look for any characters. In this case, we're explicitly looking for a period. And then we will repeat this pattern multiple times, specifically 4 times, and then we'll remove the period at the end and then have the closing parentheses. Now, the idea here is that the parentheses indicate that I want to actually capture what IP address I find, and then we want to return the tokens. And then as in previous videos, I'm going to leave the semicolon off at the end so we get a little bit of noise in the command window. I'm going to go ahead and clear my workspace so that we can start over from scratch, as well as clearing our console. And let's go ahead and run this. And so we'll see here that I get a 1-by-1 cell array. This one's not going to be all that interesting, because at this point I should just be capturing the IP address. And the idea is I want to be able to capture the IP address, the MAC address, as well as the type of ARP entry. And so you'll notice here that we have a series of spaces. And what we can do then is we can specify that we want to capture any white space, followed then by the plus quantifier that will indicate that we want to have one or more. And again, what you can do is you can take a look at the meta characters and the quantifiers in the Matlab help. We'll play around with this. We'll see if this is the right one to match. And then again, we'll test our results to make sure that we haven't accidentally lost our IP address. And so far that looks promising. Now note here, I'm not actually capturing the spaces because the /s is outside of the parentheses. That means that we can move on then to the MAC address. And again, we can use a couple of different variations of the regular expression here for the MAC address. We are on a Windows machine, so we have our dashes instead of our colons. And we are also ultimately going to need to check to make sure that it is a hexadecimal value. In other words, that values are from 0 to F. In this particular case, though, since I am pulling from a command, or ultimately will be pulling from a command, in other words, I'll be using the ARP function in Windows, I am not too worried about being passed a bogus MAC address. So in this case, I'm going to be a little lazy, if you would, and I'm simply going to look for the pattern of /w. And again, you can simply go to the Matlab help on the regular expressions to see that it is any alphabetic, numeric, or underscore character. And more importantly, we want to specify exactly how many we want to capture. In this case, since we know the pattern for a MAC address, we can simply specify the 2 followed by a dash. Now, again, this one's going to get a little bit long, much like we saw in the earlier videos, and there is technically some tricks that you can employ to repeat a pattern, but we want to keep this example simple because it's already going to get complicated enough. And so I'm going to just brute force this pattern then for the MAC address again. So copy it twice, 3 times, 4, 5, and then 6. And then if you notice, the last portion of the MAC address does not have the dash. And so we're just simply going to close that in with the parentheses. And again, we want to check to make sure that we're actually accomplishing something. And it looks like we are. So let's go ahead and give this a shot. So we'll look at results, curly braces 1. And then what we're going to do is drill into the embedded or the nested cell array. And so we'll look at results 1, 1, which should be our IP address. and then results 1, 2, which should be our MAC address. And if you notice, we have captured the entire MAC address. So things are looking really promising at this point, which then brings us to the third part of the table that we're going to be interested in capturing, and that is going to be the state or the type of the entry. And in this case, we have dynamic. But if you go back to our console for just a second, you'll see that we have static and or dynamic that we have to deal with. And so we actually want to capture whatever that third column is. And now if it has spaces or other characters in it, we might end up with a problem here. But in this case, we're going to just leverage our /W one more time, since it's been helpful for us in the past. And again, we're going to look for the pattern of a /S plus between the two columns. In other words, basically white space characters between the two columns. And then in the parentheses, we are simply going to capture the /W plus, then for the static or for the dynamic. And again, now run this and you'll see that we have a 1x3 cell array, which is again looking very promising. Our second entry is still the MAC address, and now the third entry should be dynamic. Now, before we move on, it probably wouldn't be a bad idea to check if this captures some of our other values, and specifically, let's go ahead and grab the second row. And in this case, I'm going to be a little bit careless. I'm actually going to capture some of the spaces before and after just to see if it has any impact on us. We're simply going to use our sample variable one more time, and now I'm going to pass the rest of it in, and I'm actually going to add a few more spaces after the word static. Again, just to sort of get an appreciation for how this works and to see if it actually affects our results. And you'll see that once again, we actually get a 1x3 cell array, which again looks very promising here. Now, I'm going to look at the first entry, and it's my IP address. Second portion of it should be the MAC address, and sure enough, it is. And the third entry should be the type of the entry in the ARP table. So far, it looks like we're on the right track to gathering the values in the ARP table. So what we want to do is we want to move on to the next step, and that is to actually collect, if you would, the output from the command directly. In other words, what we're going to do is we're going to use Matlab to run the same command that we would otherwise run from the command prompt. But this time, we're actually going to capture the results inside of Matlab and then attempt to parse them using the regular expression that we just discovered. So let's go ahead and give this a shot. We're going to start off again with our status and our command out. And we're going to run the system command in Matlab. And if you have not yet done so, I encourage you to look up how this works. I'm going to briefly pull up the help here, but basically we're going to be using this overload here where we can pass any command that can be found on the command line, and we are returning the command out. In other words, whatever is printed to the console, as well as the status or the return value for the console. And in this case, we are just simply going to hard code the command. In other words, we're going to do our ARP-A. Now, notice we don't have to have any path here or anything like that, which is why I mentioned earlier that it doesn't matter where you run the ARP command from. So we don't have to worry about, for instance, changing into a system directory or anything along those lines. And again, what I'm going to do is I'm going to run this without semicolons because I want to see the noise. And in this case, you'll see that I get the exact same results in Matlab as I did from the console. And more importantly, it is now captured in the CMD out variable. And you can verify that by just checking it in the command window, as well as doing something like the length of the command out. And you'll see that sure enough, yes, there are 1,280 characters. Now, what we're going to do is we're going to play around a little bit with our results regular expression. And this time, instead of running it against sample, what I'm going to do is I'm going to run it against our command out. So what we can do is we can just simply copy and paste our little test here and replace the sample with CMD out and run it again, and you'll see that you get a whole bunch of 1x3 cell arrays. And that's great because effectively every one of these entries corresponds to a row in this table. Now, let's drill into a couple of these just so you can appreciate what's going on. We'll start off with our results, curly braces 1, curly braces 1, because effectively this is going to look into the first entry in this 1x18 cell array and then look into the first entry inside the 1x3. Sure enough, it's the IP address that we had first discovered when we first tried this. If we look at 1.2, then it's going to be the MAC address associated with that row. And then finally, the type. And if we want to just pick a row in general, let's say 5.1, well, that's going to be 224.0.0.251. And if we come over here to the command window, take a second, 1, 2, 3, 4, 5. Sure enough, there is that IP address. And we can verify again by looking at the MAC address. And I'm just going to focus on the FB there at the end. And it looks very promising. In other words, it looks like we're able to pull all of the MAC addresses, all of the IP addresses and types from this table. However, there is a problem here. We now lose which interface they are associated with. And generally, it's the IP address of the interface that you're probably going to be more interested in capturing. So what we want to do is we want to tweak this particular example just a little bit more so that what we can do is we can actually grab each of these tables individually and then parse them, capturing both the IP address and the information associated with that particular interface. And this is where this example gets a little bit trickier. What I'd like to take a second to point out is the pattern that we're looking for isn't perfect. In other words, if you notice here, we have a block with an interface, a set of IP addresses, a set of physical addresses, and a set of types. And then right here at the end of the table, we may have either dynamic or static or possibly some other value. But more importantly, you will notice that then we have a new line followed by a second new line to start the second portion or the second entry in this table. In other words, for the second interface. Now, keep in mind, I have 3 interfaces on this particular computer. I may have more. For instance, if you've plugged in a USB wireless card or something along those lines, you may end up with many, many more interfaces. So we not only have a indeterminate number of interfaces at the beginning, we also have a problem with where the last interface doesn't have those 2 new lines. And again, this is just simply how this particular command functions, but you'll notice that I only have 1 new line, and essentially it's the one that brings the carriage return down to here, and then the command returns. But the problem with it is if you drill into the results of the command out, you'll notice that there is only 1 new line. So the point is that I'm going to have a hard time capturing the individual pieces of this table. And again, as promised earlier in the video, I'm going to post some of my non-working regular expressions in the comments for this video. But what I'd like to do is I'd like to focus on the trick that I ultimately decided to employ. And so I figured, well, if all of the other tables have 2 new lines, why can't I simply add a new line to the bottom of the last table, which you could argue is cheating because effectively I'm manipulating the output before running it through the regular expression. But what this does is it allows for me to significantly, rather easily, much more easily, find the individual tables. So let's get started and I'll show you how I went about doing this. So the first thing I did is I took my command out and I simply added to the command out the character that corresponds to the number 10. And if you're not familiar with this, you can look up the ASCII table and you'll discover that 10 is the ASCII number for the new line character. And there's a couple of ways that you can do this in Matlab. You could have also used the sprintf function. But at this point now, when I run my command out, you'll see that I now have 2 new lines. And again, you could argue that this is a little bit of cheating, but it helps us significantly when we determine the pattern. So let's get started now and let's look at what pattern we need to determine what portion of this output. And specifically what I'm doing is I'm going to look at this pattern where it starts with the word interface, followed by an IP address, followed by a whole bunch of other stuff that I may or may not immediately be interested in. And so what we're going to do is we're going to attempt to capture all of this block into a separate variable. So the first thing I'm going to do is I'm going to create a variable called interfaces. And the idea here is that it's going to capture the results of my reg xpi. I'm going to pass the command out, and then I need to think about what I want this particular regular expression to look like. And so I want it to start off with the word interface because that is a common thing between all versions of these tables, followed by a colon, followed by a space. I then follow this up with the IP address that I wish to capture with the same pattern that we used earlier of the /d plus and then /period to explicitly specify a dot between the octets. I then repeat this pattern partially 3 times and then remove the /dot for the end because, again, we only have 3 dots and not 4. And then after that, I don't really care what comes until I look for those 2 successive new lines. And again, this is where I had to do a little bit of experimentation, and I'm going to show you how I had to go about doing it. So first of all, I'm leveraging the dot by itself. And again, encourage you to look at the regular expression help, and specifically the dot represents any single character, including white space. And well, that essentially means any of the characters that come after the IP address. So ideally, I would just simply want to match all of these characters all the way down here to the word static. Now, if we do this by itself, it's only going to match a single character. So we have to have some wildcard or quantifier with it. And in this case, we can choose between either the star, which is 0 or more times consecutively, or the plus, which is 1 or more times consecutively. And so what I'm going to do is, since I know I have multiple values afterwards, I'm simply going to use the star. And then at this point, then I want to follow this up with the /n/n. In other words, those 2 new lines I keep talking about. And then we simply want to mention that we are going to capture the tokens. Now, if we run this, you'll see that I get a 1-by-1 cell, which seems promising, but it isn't exactly what we had in mind. So we'll look at our interfaces, curly braces 1, and then we can drill in technically the first entry, and we'll see that we captured the IP address by itself. Well, maybe we're interested in capturing all of the first table. And so what we'll actually do is we'll back out the parentheses all the way around all of the characters. And optionally, we can go ahead and include the 2 new lines as well. In other words, basically what I want to do is I want to capture the 3 tables in their entirety. And again, now all this does is it simply changes what I have captured in the variable. Well, that gets us closer to what we want, but it's still not exactly what we want. And you'll notice here that I'm capturing the entire table. Why? Well, because I appended 2 new lines, or rather I appended a second new line down here at the bottom. And what we're seeing is that the regular expression is being greedy. Now I want to take just a second, since this is a new topic, pull up the regular expressions, and you'll notice that down here under the modes, I have the ability to specify whether it's greedy. In other words, if we don't put a mode afterwards, by default, it's going to be greedy. We want it to be lazy. In other words, we want it to match the first pair of new lines. And so what we can do is we can simply add then the question mark to the end of our pattern, and specifically after our dot star. In other words, we want it to keep looking for characters up to the time when it finds new lines, a pair of new lines rather, but we want it to stop as soon as it finds the first match and not be greedy and continue all the way to the end. And this little change right here will then result in 3 cells. And specifically, if we take a look at our interfaces 1, 1, it will capture the first table in its entirety, and 1, 2, sorry, switched my indexes there in the wrong order. 2, 1 will capture the second table, and then 3, 1 will capture the third table. And so you can see here now we are a long ways, or rather a lot closer to getting the results that we wanted. In other words, we want to be able to group these by table. So we're gotten a lot further now just with that one slight little change. In other words, basically I'm saying that I don't want to be too greedy when I'm attempting to capture characters after the word interface. Well, what we can do now is, since we have 3 results, well, what we can set up here is, how about if we call this interface index? And what we will do is we will simply loop through, and either using the size or the length, it doesn't really matter. We can see here the behavior difference. If I do the length of the interfaces, you'll see that I see 3. If I do the size, we'll get both dimensions. And in this case, we would simply have to specify the second dimension. Either works. And what we'll do is we'll simply loop through each of the interfaces looking for 2 things. And since this is an IPv4 example, we will simply use the results, or rather the regxpi, and get the results from the regxpi, looking at the individual interfaces. So in this case, interfaces, square brackets, or rather curly braces, sorry, wrong language, interface index. And then in this case, we're going to drill in and get the first entry in that cell, much like what we were doing here from the console. And so we'll do it again one by one. We want to look at this table explicitly. And what I can do is I can simply just pull out the IP address by using the /d plus /period pattern. And again, we'll leverage the tokens. Now, to test this, to make sure that we don't have any problems, I'm going to simply copy and paste this into the command window. And I'm going to manually code in the index of 1, 1, just to make sure that we have our pattern correct. And you can see here that I'm actually capturing multiple IP addresses. In other words, we're capturing all of the IP addresses in the table. I'm interested, however, in only the one that is immediately following the word interface. And so what I'm going to do is very carefully insert in the regular expression, again, the word interface. And so now if we rerun this one more time, I'll come down here and do the same thing with our test pattern. You can see that I have a 1 by 1 cell. And if we drill into the IPv4, curly braces 1, curly braces 1, you just get the IP address of the interface. All right, so that's step 1. The next thing that we want to do is we want to capture the entire ARP table for that interface. And again, what I'm going to do is I'm simply going to create another variable here. I'm going to call it ARP table, or rather, let's call it the interface table because it is by interface. And what we can do here is then run our original regxpi that we discovered early on. In other words, the pattern of the IP address, the MAC address, and the status, and it won't accidentally capture the IP address associated with the interface. And so again, what we're going to do is very carefully then borrow our regular expression that we worked on earlier. We're going to run this again against the interfaces, curly braces, interface index. And again, we're going to drill into that nested cell array. We're going to look for the pattern. I think I missed my single quotes there. We're going to look for the pattern that we worked on earlier. And again, like in the other examples, we are going to specify the tokens. Now, this line of Matlab code got a little longer than I wanted it to. So what I'm going to do is I'm going to use the line extender here, and then we can see the entire command. And again, for that particular interface now, what we can do is we can parse just the table. And so I'm going to drop this down here in the command window one more time. And I'm going to verify this works by simply hard coding the 1 in it, just to make sure that we don't, in fact, have any typos. And it again looks like we have something promising here. So interface table 1. And you can see there's my first IP address. If we go with our 2.1, there's the second IP address, 3.1, third IP address. And if we look, here's the MAC address and so on, much like what we saw in the earlier videos. Now, what I want to do is I want to combine these two things into one nice, pretty report. And so we could start off by generating an empty cell array. I'm just going to call it report because I can't think of a better name. And what we're going to do is we're going to keep track then of the row count associated with the report. So we will simply say the size of the report. And we're going to look at the number of rows. So we're going to specify 1 as the second parameter. And initially, that is going to be 0. And we're simply going to add rows to the report. And we will simply do that by saying report, curly braces, row count plus 1. Neat little trick that Matlab lets us do. And in that first column, what we want to do is we want to store our IPv4 address. And if you take a look real quick, you'll notice that it is a 1-by-1 cell, and that's perfectly fine, but perhaps you actually want to store this then as a character vector rather than a nested cell. Doesn't really matter, depends on what the results are going to be here. But what we want to do then is we want to pass, and let's take a quick look at the IPv4. You'll see that it is a 1-by-1 cell. Let's go ahead and drill into this and then convert it to a character vector. And so this just eliminates some of the problems you may have with exporting the value, for instance, to Excel. And so I'm going to put a little note here that this is essentially converting the cell to a character. Again, we will do this for the rest of the columns very carefully. And so what we want to do is we want to do this now for each of the rows in the report based on the number of rows we found in the interface table. So what we'll do then is we'll take this piece and we'll put it inside of another for loop. So again, we look at the interface table. How about if we call this then interface table index to indicate that these are the results of the interface table. We'll start off with 1. And then again, what we can do is we can look at the interface table, the size or the length of the interface table. In other words, basically, it's the number of elements in each of these tables, whether we use the length or the size function, again, does not really matter. If we use the size function, we will simply want to specify the rows. And then the other thing that you want to do, just to make sure that you get your bearings correct, is that you, again, need to remind yourself of what the interface table looks like. and that it is a nested cell array. And so one, curly braces 1, curly braces 1 will give you the first value in that first cell array. If we do then 2, 1 will get us the first value in the second cell. So essentially now you want to think of the first index as being the rows and then the second index being the columns. And just to see what I'm talking about, if we do 2, 2, you'll see the MAC address for the second IP address. And so what we'll do is we will very carefully move this code inside of the for loop. Take a second to tab it over so it looks appropriate. And then we will take our interface table. We will access the first column using that interface table index, and we will drill into the nested cell array. In other words, we're going to look at the first element in that nested cell array, and that will be the IP address associated with that table. We'll do the same thing now for the third column, and we will pull from the second portion of the interface table. In other words, this is the MAC address associated with a IP address in the row of the table. And then lastly, we will look at the type or status associated with, again, that IP address for the entry in the ARP table. So quick note here, this is the IPv4 of the ARP table. This is the MAC for the specific address or for the IPv4. And then lastly, the type of entry. Now, if we don't have any typos, it's probably about time to run this whole thing and see how it works. Again, I'm doing this all live here, so perhaps we'll have an error. Go ahead and clear this. Go ahead and run it. And if we take a look at our report, we have an 18x4 cell array that has the IP address of the adapter or the interface, the IP address in the ARP table for that particular interface, the MAC address, and the type of entry. And again, here you could see side by side what I have accomplished. So anyway, this was an interesting question. I had a little bit of fun with this one. I know this video ended up being a little longer, but hopefully you can see then the power of regular expressions in day-to-day applications. Again, we're simply using console applications here, but the same thing can be done with a file. Perhaps somebody saved the output of the ARP table into a text file and provided you the text file. It'd just be a matter of then of opening that text file and reading the contents of it out before you do these steps. Also, hopefully you have been now interested rather in regular expressions, see where the fun is in trying to discover a pattern. Sometimes somebody will ask you a question and curiosity might get the better of you and give you an opportunity to dig into it. Do intend on doing more videos like this. If you have any suggestions about things you would like for me to help you discover pattern-wise, don't hesitate to leave them, in the comments. In future videos, I plan to look at things like hyperlinks, scraping a Wikipedia page, and so on. And as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.